We got a couple things going on here right now. Don't really worry too much about this stuff yet. I'll bring that in when we need it. We need to talk about what a central angle is. Okay, and by definition, a central angle is an angle whose vertex is in the center of a circle and sides are radii of the circle. Okay, so we're talking then about this green angle. Okay. Okay, that green angle is referred to as our central angle. Okay, that side right there, A to C, is a radius of our circle. I'm trying to click on it, won't let me. That's why. All right, so that is a radius of our circle. That is a radius of our circle. Okay, so the angle that is created by those two radii, as long as the vertex is on the center and A is the center of the circle, we have a central angle. Okay, what I need you to understand. Oops. That is not a central angle. Okay, even though it's in the circle, we'll talk about this angle at some point, or angles like it, but that is not a central angle because the vertex is not the center of the circle. Does that make sense? For the exact same reason, that is not a central angle. Okay, it's not a central angle until the vertex is the center of the circle. That then would be a central angle. Is that okay with everyone? Okay. We will talk about all those other. We'll talk about that angle. We'll talk about that angle where the vertex was down here on the circle. But right now, we're only talking about that angle right there. Okay. And we see at that angle, they're saying is 77 degrees. Okay. And I can change that. My limitations for that angle are 0 degrees because 0 is not an angle anymore, right? So it's got to be greater than 0 degrees, and it's got to be less than 360, okay? Because when it goes to 360, it generates back down to 0 degrees, right? Okay? So inside circles, when we start dealing with circles, that's where we start to talk now about angles that are bigger than 180 degrees, okay? This central angle is very important. Now, I've got some rounding here that I want to fix, so let's go 2 decimal places. We see that this central angle, this green angle, is every time I move it and change it, you see that that red distance out here, this red shape also changes, right? Okay. Does anybody know what a portion of a circle is referred to as? Say again. If it's half, it's a half circle. Okay, and we'll talk about. There's a better name for that. Hemisphere is part of a sphere, so I mean, there's similarities. There's what we learn about this stuff will transfer into 3 dimensions and talk about hemispheres. You know, because I think a lot of us are wanting to say this right now. Let me see if I can change this. Okay, a semicircle is going to be. I can't. That's about as close as I can get it. Is if that angle is 180 degrees. If the central angle is 180 degrees, this red shape would be a semicircle. This blue one would be a semicircle. Which semicircles are special types of these things, special types of portions of circles. What is a portion of a circle called? A portion of a circle or a part of a circle is called an arc. Okay, have we heard that before? No? Okay. All right, so that that red shape is referred to as an arc. And the way we write this, okay, is we use the endpoints, C and D. Those are the endpoints for the arc, kind of like their endpoints if it was a segment, right? If it was a segment, we would put a symbol of a segment over the top, right? But it's an arc, so we put the symbol of an arc on top. And that's the notation that we use for arcs, okay? Now, CD is a unique kind of arc. It's a special type of arc. We have multiple types of arcs. Semicircles are one of those types. This is a minor arc. Minor meaning what? Small, okay? Any minor arc is going to have a degree that is between 0 and 180 degrees, okay? And that symbol right there, that's called theta. It's just what we're going to use for referring to the arc value, okay? So this thing here is always going to be between 0 and 180 degrees for a minor arc, okay? A major arc, because if you got minor, you're probably going to have major, right? Okay? Every time that I, or that you, or that anybody takes a central angle, okay, and draws that through a circle, they're going to get two arcs. They get the red one, which is our minor one, but you're also going to get that blue one. And that blue one, would you agree that blue one's a lot bigger? So that blue one's going to be the major arc. Okay? What are the endpoints of that major arc? C and D again. Okay? Now, if I wrote arc CD, and I wanted everybody to look at the blue one, and I just say, hey, everybody look at arc CD, are some people going to look at the blue one? No. Are some people going to look at the red one? Yeah. Okay? Well, we might have half and half. We might have everybody look at the red one when I really want to talk about the blue one, whatever. There's ambiguity. There's question about which arc am I really referring to. So, when you want to talk about a major arc, you don't use two letters. You have to use three letters. Okay? Because the third letter serves as a direction to go from the first point. So C is my first point. I want to get to D. I've got either that direction or I could go that direction, right? If I want to talk about the blue arc, then I'm going to go this direction. What is a point that I would go through before I got to D using this direction? G. So I need to label that major arc using those three letters. And that middle point is a guide for us on which direction to kind of rotate around the circle. Is that okay? So anytime they're talking about 2 endpoints, we're referring to a minor arc. 2 endpoints and a kind of a directional point here. It's talking about a major arc. If I ever want to talk about the measurements of an arc, we will add that little M that we do for angles. We'll add that little M out in front, and that will be the measurement of arc CD or the measurement of arc CGD. And that's the next thing we're going to talk about here. When we have a central angle, okay, this central angle, we have an angle of 53.64 degrees, right? Let me hide that number for now. Arcs can be talked about, or the characteristics of arcs can be described two ways. We can talk about them as their degree, which a lot of times they'll verbalize by saying, what is the measurement of arc CD? And like I said, written out in notation would be, what is the measurement of arc CD? And we would say 53.64 degrees. Okay? So you see here, if measurement of arc CD is 53.64 degrees, how does that 53.64 degrees relate to the central angle? They're the same. And they're the same all the time. Does that make sense to everyone? Okay. a central angle, and I've got that written here somewhere, right here. A central angle shares the same measurement as the arc that it creates, okay? Now, I think, at least initially, it's important for us to use that word creates, because would you guys, can you understand, do you realize or see, and when I have that central angle, that central angle cuts off that red arc, it makes our attention focus on that red arc. So that's the arc that we're referring to as the arc that is created by the central angle. Now, in of course exams, ACTs, any other math class beyond this will not use that word creates. Okay, they will use some of those words in parentheses there.
What does it mean by the same measurement? Like, if you measured up the arc, that's like you measured 50.
So we describe that arc degree to have the same arc degree there. We will talk. I think what you're trying to say is the distance of that thing.
Yeah.
Right. So that'll be the second way we talk about arcs. All right, we'll get to that here in a little bit. But degree-wise, we refer to an arc as having some type of degree, which ultimately kind of, I don't know if this is the best way of saying it, but the larger the degree, the more complete of a circle it becomes. Does that make sense? Maybe the more curvature we incorporate when there's a larger degree of that arc. So like a 30-degree arc, one, it tells you it's pretty small, but two, I mean, there's not a lot of curvature occurring there, right? But if I have a 300-degree arc, there's a lot of curvature occurring there, correct? Okay. So that it's kind of a descriptor or describer for something like that. Eventually, we're going to realize and give you some formulas in a little bit, next couple days, that relate the degree of the arc to the distance of the arc. Okay. So they are strongly related, tied together with one another. So those two values are exactly the same. I said the word creates, that's what we're looking at here. Just vocabulary-wise, when you're reading something like the Uniforce exam or the ACT, like I said, they're not going to use the word creates. They're going to probably, because it's the most mathematical word up there, they're going to use this word here, subtends. Okay? Whenever you see the, and I'll give you the, I don't know if I still have it up. We did this in the last class. Nope. I just Google subtends, and it's really not that great of a definition. It says of a line, arc, or figure form at a particular point when straight lines from its extremities are joined at that point. Okay, that's kind of, I mean, what does that say, right? Anybody read that and say, well, I have no idea what that definition is talking about? Okay, when we I guess the best way to describe subtends for you is, at least for our purposes, is it is this arc that is being created by these two radii intersecting your circle. Is that okay with everybody? Okay. Intercepts is another word to use. Intercept, if I think about sports, if I intercept a pass, maybe Mallory's going to get Saturday at school. She needs to intercept that letter to mom and dad, right? You didn't know? Maybe later we'll talk to you. But intercept means to cut through the path of. Does that make sense? Would you guys agree that if I look at this central angle, that ray is cutting through the path of the overall circle? Is that ray cutting through the path of the circle? Okay, so that angle is intercepting that arc. Okay, and ultimately that means the exact same thing that subtends means. Okay, you're going to see the word subtends though. I'm pretty confident in that. So just be on look at that for that. Intersects is of the three up here. It's the least mathematical, at least in this context. All right, so the other thing we talk about, the other characteristic that we're interested in regards to an arc is its length, okay? This is not its length, okay? This is a component to finding the length, but the length of this thing is obviously the distance that you would walk from D to C. And you're going to walk a curved distance, right? Well, we could take that distance and we can flatten it out, straighten it out, and it can give me this distance here of 4.13. Okay? That idea becomes a very, very critical component for a lot of things that we do in physics and trigonometry, and really understanding other components of trigonometry, is the fact that that distance, if I started at D and walked around to C, would be the exact same idea as putting D there and C there, straightening that curve out. Does that make sense to everybody? Okay. So if that curve's length is analogous to a segment's length, and segments we can do segment addition, segments have midpoints. What do you think we can do with arcs? Let's say, okay, I can find the midpoint. So I should be able to say, looking at that arc, I think I got to do it this way. Well, I'm not sure how to do that on Judger, but there is a, that arc is 12.57 units long, right? Can I cut that in half? Okay, so I should be able to find, 6.285, okay, which would be, the halfway point between C and D on that red arc, okay? If I had another arc up there, maybe, let's see here. Okay, so that purple arc, okay? Could I take that red arc's distance and that purple arc's distance? Can I add 12.57 and 5.5 together? Yeah. So then from D all the way around to that point there would be, about 18 whatever. Okay, 18.07 or something like that. Okay. So we can do arc addition. We have midpoints of arcs, all that kind of stuff. Okay. Ultimately, what we can kind of view arcs as is curved segments. So everything that you do with a segment, you should be able to do with an arc. Okay. That brings us into the first slide of this section. So I do want to talk a little bit about this. This is a vocabulary word that's going to be kind of very useful and allow us to move through tomorrow's stuff pretty quickly. When I connect C and D, okay, C and D are connected right now with an arc, but with 2 points, we always know that with any 2 points, there is always a segment that can be made between them, right? Okay, so if I take C to D, okay, that segment is a very, very important segment to us, okay? And you can see, I hate this thing right now, because I don't want, let's see it this way. Algebra. Say it again. Yeah, I think I'm just gonna do it. I don't know if I can do it this way though. That should work. There we go. All right. So that orange segment is an important segment, okay? And if we think about it, it shares the same endpoints, C and D, that the arc shares, right? Or the arc has. And C and D are also points that exist on those rays. So these three things, that angle, that segment, and that arc, are all strongly tied together with one another, okay? And that's kind of what I think in this section there's 12 or 13 theorems And a lot of them deal with those three things being linked together. This segment, does anybody know what that segment's called? The definite or the vocabulary word for a segment whose endpoints are on the circle? Starts with a C. Anybody heard it? Last class had heard it, or I guess fifth period had heard it before. It's a chord. Okay. Just a segment whose endpoints are on a circle. That's the geometric definition of a chord. Okay. In the one class knew it because they've been in a class where they've talked about a special type of chords, okay, or a special type of chord. If I look at this length here, 7.32, and I start, obviously when C and D are really close together, that number is very small, right? Okay, so the length, obviously, zoom in here. C and D are very, very close together, but there is still a gap between the blue line and, I guess, the red line and the chord. That's the chord. That's the arc. Okay. So as long as the points are not, C and D are not the same point, we have a chord. Okay. Now look at those distances. What are those distances doing as I move D around the circle? They're getting bigger, right? But at some stage, they start getting smaller, right? So they went from small to big, got big as possible, and then they start getting smaller. When they're biggest as possible, what kind of segment would you refer to that segment right there? That is the diameter, okay? So your chord, in this case, or your diameter, is a chord. Does that make sense? Okay. So we need to write that down. Okay. A diameter is defined as any chord that passes through the center of a circle. Okay. You may have defined this in a different way in other classes. You might have said a diameter is a segment whose endpoints are on the circle and it passes through the center of the circle. It's a much longer definition, a much wordier definition, because that right there is all replaced with what word in that first definition that I wrote? Chord. Okay? So knowing vocabulary obviously allows you to make other definitions more concise. Okay? The geometry definition that you're going to see most often written in a textbook is that a diameter is the chord that passes through the center. Okay. A lot of the stuff that we're dealing with right now for circles is then kind of overlaid into other curves. Okay. So parabolas have chords. Okay. Parabolas have tangent lines and that kind of stuff. So what we learn here in geometry about circles is going to be replayed again in Algebra 2, College Algebra, Trigonometry, Integrated 3, all those courses. Okay, so trying to build our vocabulary to be successful in those things. Your diameter is the largest chord for your circle. Okay, you cannot have a chord that is bigger than your diameter. Okay. How many diameters does a circle have? It has an infinite number. Well, what's the relationship between all of those infinite diameters? They're all the same length. Okay. No homework this evening. Okay. Since you don't have any homework, it'd be a good idea to maybe get a chunk of that take-home test finished. There are some people that have not started that yet, and I know that there will be people that do not start it at all. Please don't be one of those people. Yes.
I won't be here April 1st.